All right, my name is Erkang. I am the founder of Jupiter One and CISO of LifeOmic. So Jupiter One is a cloud-native platform for security and compliance, and more specifically, asset identification in the cloud, configuration aggregation and auditing, and metrics reporting, and so on and so forth. LifeOmic is a healthcare cloud company that builds software in AWS that are completely cloud native, that drives machine learning to analyze a huge amount of data for healthcare, DNA data and patient data, and so on and so forth. Now, before I jump into this, I got a couple questions for you guys. All right, who here, by raise of hand, who here loves compliance? We got a couple of takers. All right, very brave of you.
It's all the compliance officers.
These are the auditors. All right. Now, who here had to deal with compliance but think it's a big pain in the butt? All right, more people. That's great. The rest of you are either asleep or not quite honest with yourself. I've done this for a long time in security and compliance, and I first and foremost think compliance is a necessary evil. It's not a bad thing, but it's not anything that anybody particularly enjoy. I don't. Even as a person in charge of the compliance program for our organizations, I don't particularly enjoy it. Now, this is our compliance program, which is probably similar to many people's, right? And it's not that different. A lot of us organizations, there's little details, but overall it's similar. And we started off having a set of policies and processes and risk assessments, and use that to drive risk-based decisions on what controls to implement. So as a result, we implemented about 100, probably 130 or so controls as part of our security and compliance program. And then the fun begins, right? So pick an assessor, get all of the gap assessment done, remediations, collect evidences, and continuously monitor and manage those controls. Now, what happens is this, right? So this is the thing that my team does, right? So every time an auditor comes in, for those of you who loves compliance, we have to entertain you guys and collect evidences for you to do the audit. But then going forward, we still have to monitor and manage to make sure those controls still work after you leave. So what is wrong with this picture? Anyone? What do you think? That's right. That's one of them. Too many lines. Now, I got folks in here, right, so doing the compliance work, and I have folks in here doing the security work. Nobody wants to be those guys, to be honest. There's just too much going on, too overwhelming, too much data, too much repetitive work, and it's just not fun. So what can we do to make this better, right? So we're in cloud. Everything is software defined. There's APIs for everything. There's got to be a better way. So here's what I asked myself and my folks and say, well, a couple questions I throw out, right? Number one is I really don't need more controls. I already have enough. Now, what can I do to prove to auditors and to ourselves and the executive teams and our customers that what we have that we can effectively manage and prove that they're working? And secondly, how can I make decisions on my day-to-day operations for security that I'm making those decisions with full visibility and full confidence, right? If I'm blocking an IP, for example, how do I know that I'm doing the right things? If I'm going after a vulnerability, how do I know that that is the time that I should be spending right now, right at this moment, to go after that? So is this possible? Is this 100% visibility to drive these goals possible? So what I'll do is I'll walk down a little bit of our journey of how we do this. How do we automate this with code and with automation and data? So the idea is we want to have data-driven compliance and data-driven security using code with these steps, with automation, not with people, not with an army of people who just don't like doing what they do. So these are the things that we've done. And we build this into a product at the end. I'll talk a little bit more about that. But these are fundamentally the things that we've done to achieve that. Number one, we say, everything in the cloud is software defined already. It's got APIs, it's represented by JSON objects essentially, and you can core the APIs for those. Now, can we do the same for compliance frameworks? How about we turn the compliance frameworks into a JSON object? And what about policies and procedures? The return documentations, can we codify those as well and write them in Markdown and kind of connect them and build them together as a code repository or code package? And the third step is, can we aggregate data from everywhere, right? So again, this is a data-driven type of compliance effort. So we want to collect data from everywhere, not just the infrastructure, but really everywhere, the data that we can collect into one single source of truth. And with that data, then we can write queries to generate evidences for compliance. Now, this is similar to how log aggregation works, right? So Splunk and Sumo Logic and the presentation previously. Now, if we can aggregate logs, and maybe we can aggregate asset data, configuration data in a similar way that we can query it and have one single place that we can gather evidence by mapping those to the compliance requirements. So I'll show you how each one of these works. So here are a couple of examples of our internal compliance efforts. One is HIPAA, and the other example I'll show is HITRUST. So this is a JSON representation of a compliance standard. It's actually quite straightforward. It's got the name of the standard, what version that is, where you have the more details about that standard, and these are just some metadata. The real value of this JSON representation is the actual requirements in different sections. So in this case, what you see here is just an array of different sections, and the first section is administrative safeguards for HIPAA, and within that, it's got an array of requirements, and each one has these 2 or 3 basic things. It's got a reference number that points to that requirement, and a title, and a summary of that requirement itself. So this is a exact representation of what HIPAA says, right? So what the regulation says. Similarly, you can do the same for, say, SOC 2, right? I think many organizations are SOC 2 certified or going after that, right? It's kind of like the gold standard in security compliance auditing. You can do the same thing and represent these controls in different domains in the very similar JSON structure. Now you see that here, the only difference between this one and the previous one is that instead of sections and requirements, we have domains and controls, and in these sort of arrayed JSON representation. And it also has, each one of those has a reference number, which will be later used to map to the policies and the evidence being collected. So that's step one, right? So we have the frameworks defined in JSON. And keep in mind, you can do this for anything. You can do the same thing for NIST. You can do the same thing for ISO and PCI and so on and so forth. The structure will remain the same. Now, we have our policies and procedures. This is now returning Markdown. And out of your organization, when was the last time you've read the whole damn thing? Your corporate policies and procedures? Probably never. Other than the person who wrote it to begin with, you probably don't read it. Now, so the way that we've structured this is we say, well, let's make this more like code. Okay, so we're going to write these documents in Markdown, and rather than in long 200-page Word documents. Well, the end result may be similar, but the individual parts that are relevant to anybody's role is a lot simpler and smaller and easier to manage and update. And we link them together like how you link microservices together, right? So they're loosely coupled. And we do the same thing with the procedures and the policies. And here's a configuration that you see here as one example. A policy that says roles and responsibilities and training, that's the overall policy. And there are individual procedures in here that talks about a role assignment, the training, the awareness, HIPAA, communications, and so on and so forth. And that is combined. And each one of those is a very small Markdown file by itself. Now that makes versioning and so on a lot easier, and we check them into source code as we do other code that we develop, and the review process of updating these policies are just PRs, right? So if you want to gather feedback or if you want to make sure people review these changes, and the diffs are very nice, and you can see the differences between one version and another, they're just PRs. You can then publish them into HTML site, and this is our policy for LifeOmic security. We are very open and transparent about the things that we do, down to the actual procedures that we operate on, and they're all public, and you can or you don't have to do it. But the idea is, once that you have these in Markdown, you can turn them into any format, right? You can turn them into HTML. This is using Make Docs and build the site, or you can turn them into PDF or Word document and whatever you like. So those are the policies and procedures. And the third step is the data. This is the fun part. We have a lot of data, right? So all of those controls, and not just the infrastructure themselves, the configurations of those resources, and the controls, the security controls in place, and other type of operating data in place needs to be all aggregated so that we can collect evidence from one single place, right? So without going to 20 or 30 different places every time there's an audit. So this is what we do, and here's some of the data sources that you can see. The cloud service providers, there's AWS, Azure, GCP, and we use primarily AWS, but there are still a lot of things across these other places. Identity providers, right? So we happen to be all over the place a little bit, right? So we use Okta for single sign-on for all of our SAML applications, but back office, we use Office 365, which is Azure AD managed, and we have a few users who prefer Google Docs, and so we have a set of G Suite users as well. And we also have a bunch of data in code repos across GitHub for our public open source repos and Bitbucket for our internal source repos. And all of these other things that you can see, these are all pretty common names, and Snyk and Carbon Black and so on and so forth. Now, all of these are sources of data about your environment, right? And every single provider holds a piece of the pie that describes of your operation and your security program. Now, the idea is we can aggregate them together and build a common data model across the board so that it doesn't, regardless of the source of the provider, you can now have one place to query your information and provide that to auditors. Now, when was the last time you had to explain to an auditor what is a Kubernetes cluster? And when was the last time you were successful at that? Probably never. Now, with a higher level classification, or I shouldn't say classification, but a schema for building this data model, which is what this is, now we can represent data in your environment, or in our environment, in a more generic and understandable way for both the security folks and the compliance people. And this allows querying to be a lot more straightforward as well, so you can query data at a higher level. You can say, hey, find me all the data stores that are encrypted or not encrypted, regardless of what that might be. It may be an EBS volume, or an S3 bucket, or an RDS instance, or cluster, or DynamoDB table, whatever that might be. You can just say, give me all the data stores and show me if they're encrypted. It's just a quick example. Here you go. Querying. We actually built a query language of our own that somewhat resembles natural language to some extent. It's not natural language, but it's very intuitive when you read it. So here's a query that says, let me take a step back, right? So the idea is this. The idea is, once you have the data, now you wanna gain insight about that data, right? What questions can you ask of your data and get answers? Now, can you operate your security operations and your compliance program in such a way that's almost Google-like, or asking questions to Alexa? Can it possibly be that simple? And this is our goal, right? So in order to build this, so we build this core language to answer these questions. Now, these are just some questions, example questions, right? And the core language itself is flexible enough; you can ask anything. Now, the first one says, what is the inventory of my sensitive data store? Now, assuming that you've tagged them correctly, you can just do this. You can say, find data store with classification that is sensitive or confidential or critical, or however you classify your data. Now, whatever that label is that you've tagged your data store with. Again, like I described, the data store is a more generic, higher level concept. As the data is being aggregated, those resources are labeled data store, like an S3 bucket or a DynamoDB table and so on and so forth. And that single query can find all of them across the board. Here's some other examples. are my end user workstations protected by host-based firewalls? Right? What this does is to find some relationships. Now, one thing that I didn't quite mention is that as we're building and aggregating that data, and not only are we assigning them a higher level data model, but we also analyze the relationships based on the configuration so that there are connections that are built behind the scenes. Is actually a graph that we've built to map out those relationships and the context across that data. So here's an example of where that relationship comes into play. So what we can do is we can say, hey, find a host agent with a property that says firewall is on, and this host agent could be any host agent, right? So it could be Carbon Black, or it could be OS Core, it could be something else that identifies that the host agent or the firewall on that host is on, and the host agent may be protecting or monitoring or managing the device, right? So the end user device, and return some information about it. Now, this can be further extended if you look at this query itself. This can be further extended to find the owner of that resource. You can find the user or the person, right, assuming that relationship is already built in a graph. So that's the second example. The third example is actually an example about a manual security assessment. Now, there are manual data that we also aggregate into the same platform and source of truth without having to call the provider API, because you can use the platform APIs to send this data as well. So in this example, it says, hey, who did my assessment in the past year, right? So is it a person or a vendor or an organization that performed the assessment within the last year, right, with those timestamps, and give me the assessor's name, what type of assessor they are, and so on and so forth, right? So data about that. So these queries can then provide evidence for compliance, or just from an operational standpoint as well. Now, another interesting part is that now that you have the data, right, you can, just like security people, there are positive use cases, there are also negative use cases, right, abuse cases. Now, what we're doing is we've constructed certain queries to look for positive results as well as bad or negative and unknown results using the same query and using the same data set. So what this provides is a complete picture of compliance, right? So you can say, if the query returns me data store that are encrypted, that's great, but how do I know that that's everything? Is what percentage of that is. So we can construct a query that says, all right, find me all the data store that's classified as such, and then find me all the data stores, the second one, this is bad, we don't want any of that to happen, that are in production but unclassified, that are not labeled. And then the third one is just broader, maybe it's outside of production environment that are unclassified. We just have certain unknown resources or data stores out there. So this gives you a better picture of compliance, and from both an internal operation standpoint and to give a complete picture to the auditor, right? If you provide this data and it says, look, I gave you the results, and all of the results, 100% of the results are coming from that first query. That means I am 100% compliant, right? Now, what I can show you is then also, I found nothing from the second or third query, so you should have complete confidence in the data that I'm providing you, rather than just trusting me providing a set of spreadsheet and hoping that that spreadsheet is complete. The second example is the same, right? So find me all the data stores that are encrypted, with those classifications, and then a reverse of that, right? And say, find me all the ones that are not encrypted with those classifications, so I can identify the ones that are gaps, right? So we use this to perform gap analysis in a code-driven automated way. Now, these queries can run on a regular basis, daily, or however that they need to run to identify those gaps. All right, so the last part to complete the picture is then we want to map those to the compliance frameworks, right? So remember in the previous step that we've built these compliance frameworks into JSON to represent them. So each requirement or each control has a reference number, right? And we have policies as code now, and we have compliance evidence as code, right, as these queries. So by doing that, we can then connect the dots, right? So map them together. The policies are in this JSON format, JSON YAML, doesn't matter. And you can see that we use the ID of the policy procedure and say, well, which requirement or which compliance framework and which requirement control does that policy procedure implement, or which requirement does it meet? So using that structure, you can have a one-to-many relationship and say, this is my policy procedures, and these are all the different compliance frameworks and the requirements and controls that this one meets. Same thing with evidence collection. So here's an example question and says, the question is, which user or group or network or host has access to data that contains PHI? And we write a query for that, and then that query is mapped to various type of compliance requirements, right? You can have a collection of those, right? And it doesn't have to be PHI, it could be PII or something like that, right? Just write the query and map them to the appropriate compliance requirements or controls. So the result of this is a dashboard where we can have a complete picture of our compliance posture at all these levels, right? So do we have policies and procedures mapped to these compliance requirements? Do I have evidence being collected to show the implementation of these controls? And do I have continuous monitoring and gap analysis for these controls to continuously detect gaps and alert the security team about these gaps? So that's the dashboard for compliance. And you can see all of these in one shot. And this particular one is HIPAA. And again, everything is just JSON, right? So you can replace this with any framework and any JSON, and you will have a very similar view for those. This is the end result. The end result of our operations is now greatly simplified. We don't have that many dots anymore, or that many lines that we have to connect. We have one aggregated system, one aggregated platform where we just use automation to collect the data, and we just have folks write queries and map them to it, and do this once, and maybe continue to tweak it a little bit, but it's a much simpler, much more efficient effort, and we gain continuous visibility to this as well. Now, before I finish, I want to touch on this, right? So I talked a lot about compliance, but this is not just compliance, and there are a lot of use cases. Now we have this data. Then imagine what else you can do with this data. What else you can do to gain asset or to gain insight into that data itself using the graph data model and the queries on top of that. We can do all sorts of things. All of these things are possible. And I'll just show you a couple of examples using those queries and see those graphs. And this one is an analysis of our S3 environment that says, hey, find me all the S3 buckets, right? So this is the query itself. And that allows access to somebody, and where the originating account name of the bucket is different than the principal or person that the access is granted to. So this effectively shows me access to S3 buckets that are now within the same account. And here's an example of single sign-on access between an Okta user and an IAM role that is returned by the query. And another example here shows you the vulnerability status of a code repo, right? If you have vulnerabilities from Sneak or from Veracode or from somebody else, and you can quickly determine by having these relationships built and show you now which developer most likely contributed to that vulnerability. Now using the timestamp and correlate that to the recent PRs made by the developers, you can kind of extend that correlation almost end to end. So those are some of the examples, right? So these queries can then be turned into alerts, right? So we have an alert dashboard that you can trigger emails or Slack messages or Jira issues and so on to be created. And this is the product that we end up creating, Jupyter One, to show you this. And last but not least is you can actually build metrics and charts and also using queries. So these are just some of the examples of use cases of what you can do with that aggregated data and the graph and the queries on top of that. To us, this has become our internal knowledge base for security and compliance, right? Not just to generate compliance evidences in a code and automation-friendly way and cloud-native way, but also it has become the core of our entire security program or we can just come in here and ask questions, right? If we need to find something about our environment, whether it's part of an incident response exercise or just part of a continuous configuration hygiene program. Now, this is what we have been using for ourselves. This allows us to take actions with confidence much faster. So that's it, and I'll be around to answer questions, or if you'd like to see a demo of the actual product, I'd love to do that for you. And my colleague David, there wearing the Jupyter One t-shirt, is going to be around as well if you guys have additional questions for us. Do we have time for questions?
Yeah, we could do maybe one or two.
All right. Any questions?
You didn't get to ask one earlier, sorry.
I think it's a great system. I am part of the compliance program. I see that a lot of value. One question I have is that you have put a middleman between the reality and the auditor. Auditor is, instead of going to the real system, they can look into this system and get all the answers. But will the government auditor accept these, or they will still insist on going to the actual system and finding out the truth? So what is your experience?
Yeah, it's a level of trust, right? So you have to build that level of trust with the auditors. And of course, you have to educate the auditors once. Keep in mind, you have to educate them once, how this works, and show them how the data is collected and how the query is run. And this actually brings additional trust to the auditors, so that instead of the auditor saying, oh, you're giving me a spreadsheet that I hope came from the source, and that I hope is the complete picture, right? You can kind of see that the queries represent different aspects of that data. And you can see that the system collects that data automatically without human intervention. So as a result, we actually built a stronger trust with our auditors with the data that we have, and we can show them.
Any other questions? Yes.
When you're building that trust, is there an auditor there verifying whatever that process is that you guys are automating to verify that it is correct? Or how do you get that trust?
Yes, so the auditors sometimes do ask those type of questions. So we show them how the system works. And in some cases, it depends on the auditor, right? So sometimes the auditors are comfortable with technologies. And sometimes you just show them a couple of examples and say, hey, this is what this looks like by a direct query to the AWS APIs, or this is what this looks like in the AWS console, and this is the equivalent of what this looks like as the result of a query, right? You give them a couple of these examples, and they see, though, yeah, they're in sync, and they're the same, and then they start to trust the queries and the aggregated data, right? And it's the same concept, right? Do auditors trust outputs and so on from Splunk? It's just a level of understanding that you have to build up to.
All right, one more while we get John up to the stage. No? All right, another. Yes, there is one. Justin. Thank you, Justin.
There are some other efforts around trying to standardize things, like OSCAL, which is working on things like that. Have you kind of looked at how to integrate these kinds of configuration descriptions, what you're doing? I mean, yours looks quite nice and simple, whereas OSCAL is kind of XML based.
So I'm not quite following the question. Are you asking about other similar kind of asset aggregation solutions?
Other sort of formalized policy description tooling.
Maybe I'll follow up with you offline on that. I wasn't quite following the question. I'm sorry about that.
No problem.
Yep. All right. Well, thank you.
Yes, thank you so much.
Yep.